The sum of the first n terms of a geometric sequence is given by this formula. Question A, given that Sn converges, find the range of possible values of C. Let's consider when it converges, when it diverges. If it's a geometric sequence and when the absolute value of a common ratio is less than 1, if n increases, the general term un becomes closer and closer to 0, or the absolute value of un decreases, and limit exists, and this limit is equal to 0, and just the sequence is also convergent. And if we say about the sum also tends to some value. And what is this value? It's sum to infinity, and it's what u1 1 minus ratio. So limit for the sum also exists, and we say that Sn converges when the absolute value of common ratio is greater than 1. If n increases, un tends to plus or minus infinity, so limit doesn't exist, and we say that sequence diverges, and also sum does not have limit, so it also diverges. It means that it just tends to plus or minus infinity. So to be convergent, the absolute value of common ratio should be less than 1. Common ratio is just this value which is to the power of I, it's log to the base 2 of C, but if it's difficult you may write a few terms to be it more clear, and you can see that the first possible value of I is 0, so substituting 0 for R, we get that it's 5 plus 5 log 2 C and plus so on, and it's quite clear that common ratio, it's what the second divided by the first, and it's log 2C, and the first term is 5. So log to the base 2 of C, and its absolute value should be less than 1, and it means that this value should be greater than -1 and less than 1. Let's consider graph of log to the base 2 of C, as argument, and it looks like this. When base is greater than 1, log to the base 2 of x in general looks like this. When base is from 0 to 1, it looks like this, and it passes through 1 0, and it's log to the base 2 of C, and we need it to be, or values to be, in between -1 and 1, and you can see that for C it becomes from this point C1 to this point C2, and C1 can be found as point of intersection of what? Log 2 C and -1, and just by definition C is what? 2 to -1, it's a half, and log 2C is 1, it's C is what? Just 2. Hence solution is C is greater than half and less than 2. The next question B, in the case where C is 1.5, find the least value of n such that sum to infinity minus Sn is less than 0.1. And just using formulas which are given in a data booklet, sum to infinity, it's what? u1 1 minus ratio u1 is 5, 1 minus, and ratio is log 2c, log 2 over 1.5, and Sn is u1 5 ratio to the power of n minus 1 and ratio minus 1 and divided by ratio minus 1. And you may consider two graphs and then find point of intersection. I would like to consider one graph and consider such function this absolute value minus 0.1, and then I need it to be less than 0. Less than 0. So using a calculator I enter one function, absolute value of sum to infinity minus Sn, and then minus 0.1, then window, and since we need x intercept with 0, it may be from some negative y value to some positive y value, and choose some x values. Definitely x should be positive, and graph, and we need this point of intersection. It's x-axis, so we need 0, 0, left, right, guess, and since n is integer and we need this function to be less than 0, we round up. So n is 9. And that's all for this question.